Find the derivative of 3y minus 2x quantity to the sixth equals 7 minus xy. We have here an implicit equation, an equation involving x and y that is not solved for y in terms of x. And it's not possible to solve for y in terms of x, therefore we'll have to take the derivative implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. On the left side, we start with the power rule. Bring the power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside. The derivative of 3y will be 3 and then times y prime, because we just took the derivative of a y term. Every time we do that, we get a y prime. The second term minus 2x, the derivative will be minus 2. Equals 2. On the right side, we have the derivative of 7, which is a 0. And then the second term, negative x times y, is a product rule. The derivative of the first, derivative of negative x, is negative 1 times the second left alone, y, plus the first left alone, negative x, times the derivative of the second, which is a 1, but then multiplied by y prime, because we just took the derivative of a y term. We have two terms here that have a y prime in them. This one, though it does have all of this that will distribute with it, and we have this one. We want to isolate those to one side. We have to start by distributing the 6 times 3y minus 2x to the fifth on the left side. So if we distribute that in, we will first multiply this with this 3y prime. We can multiply the 6 and the 3, that is 18. We have the y prime, and then we have the 3y minus 2x to the fifth. In the second term, we multiply all this with the negative 2. We can multiply the 6 and the negative 2. That'll be negative 12. We then have the 3y minus 2x to the fifth. On the right side, the 1 is implied, so we can write that as negative y. And again, the 1 is implied, so we can write that as negative xy prime. We want to isolate the y prime terms. The one on the left is already positive. The one on the right, if I move it to the left, will become positive. And that means this term needs to move to the right, which in this case it will also become positive. So we have 18 y prime times 3y minus 2x to the fifth, moving over, adding over, xy prime, equals to moving over, adding over, a positive 12, 3y minus 2x to the fifth, since it did not have a y prime in it, and then we also have that minus y, which will stay there, because it also did not have a y prime in it. We've isolated the y prime terms on the left, and we can now factor a y prime out. And that will leave us with 18 times 3y minus 2x to the fifth plus x equals 2. And then on the right side, we will leave it alone. We can now solve for y prime by dividing both sides by what's inside of the square brackets on the left side. So y prime will equal 12 times 3y minus 2x to the fifth minus y divided by 18 times 3y minus 2x to the fifth plus x. It might be tempting to cancel out the 3y minus 2x to the fifth in the numerator and denominator, but in order to do that, we have to factor it out, and it only exists in the first term in the numerator and denominator, not in the second term, and therefore it cannot factor, and therefore it cannot cancel. So it remains alone in the first term of each, and there's our derivative, y prime.